Hello everyone, this is the first video about Chapter 4, Repetition Structures. We are going to spend a while on it. This is one of the most important and prevalent things that you have to do as a programmer. And let us start with it. Introduction to repetition structures. We will talk about a while loop, condition controlled, which is a condition controlled loop. It's the same condition, Boolean valued condition, which is true false, as we used in if statements. We will also use a for loop, that is count controlled loop, and that is repeating the same chunk of code a certain number of times. So there are two ways how you can repeat certain statements, repeatedly execute certain statements. That is by condition. As long as condition is true, you repeat the statements. And by count with a for loop. Before we go any further, we will use something called a counter. Counter can be used with either of these two loops, not just count controlled loop, and should be used with either of these two loops. We will calculate running total, use sentinels, learn about input validation loops, nested loops, and in the end we will do a little bit of turtle. All right. So often we have to write code that performs the same task multiple times. Duplicating it would be notoriously large. Say you have to repeat pretty much the same task 1,000 times. And if you need to update it, you would have to carry on updating for every copy of that code. Instead, we use a repetition structure that will make computer to repeat code as many times as necessary. First kind of loop is a while loop, condition-controlled loop. First of all, we will need a condition. Condition will be tested for true or false. If condition is true, the loop is repeated again. General format, while condition, use execute statements. Condition is a Boolean. It evaluates to true or false, and it's the same sort of condition that you used in if statements. So this is a general logic of a while loop. Notice there is a diamond condition and there are two exits, false and true, just like it was before for if statement. If true, execute statements, just like before. And the difference with if statement is what happens after you executed these statements, in case condition was true. You loop back to the checking the condition again. If condition is true again, you repeat the statements again. So we will need to talk about a way to control the loop to stop executing, because you don't want to a program to continue until you force it to stop. You want to a user, for example, to be able to interact with it and make it stop, essentially. So for that, something needs to happen inside the loop to make the condition false. Before we go on, we will use the word iteration, that is one execution of the body of the loop, and that is executing the statements that are inside the while condition, and they are the ones indented inside. So rules of indentation are the same. If we go back up to general while condition, you see a colon and then indented statements. So the indented group of statements is the statements that are executed inside the loop. If there are further unindented statements, they are only executed after the loop exits. All right. We also call a while loop a pretest loop because basically it tests the condition before performing an iteration. So in order to enter the loop, your condition has to be true to begin with. And to make it true, you might have to, almost always have to define a corresponding variable before the loop and set it up so that your condition is true. There is a little bit of a schema here, and feel free to read it. However, I'd like to start differently. I'd like to show you a problem, and I will come up with essentially the same sort of the code corresponding to that flowchart. So hopefully you are watching this on a computer screen and not on the phone, and you can actually read the problem. Whenever you see a story problem, you read it 1, 2, 3 times, as many as you need to remember and begin understanding it. So this is a commission calculator for some salespeople, and the idea is you need to compute commission amounts for a number of salespeople. You ask them their sales amount, total value of goods or services sold, and their commission rate, so percentage that they take home of their sales. Then you calculate the commission as sales times commission rate. For example, Emily sold 80,000 in goods and her commission rate is 10%. Then her commission will be 8,000, that is what she takes home. And using tools from chapter 2 and chapter 2 only, we can come up with this code. Basically, ask the user for sales, enter your sales, then immediately convert it to float. Ask the user for commission rate, so I ask user enter your commission rate percentage, that is a number, then I convert it to float and I divide it by 100. Why do I divide it by 100? Take a moment, take in this code and think it through. Yes, I divide it by 100 because the person will be entering, for example, 10 for 10%, and to convert it into a fraction, I divide it by 100. Now here is a formula. Commission is a new variable that is equal to sales times commission rate. And finally, I print your commission is in dollars and value of this variable commission. Now look over this again and notice that there are 3 variables here. One is sales, the other is commission rate, and the third one is commission. This is a calculated variable, and the previous 2 variables are from the user input. So if I run this program, and indeed it runs, enter your sales, for example, 80,000, commission rate 10%, 8,000 is your commission. And you could keep rerunning and rerunning this program for, say, different people to compute their commissions, or for you to compute their commissions for your employees, for example. But that is highly inefficient and excessive. So we are going to edit this code, and so far everything here is from chapter 2. If something looks unfamiliar, better go back and check it out. Alright, so I'm going to make this program work as many times as I need to with a while loop. I will introduce an extra variable, keep going, and I will initialize it, in other words prime it, sometimes the book uses this expression, to y for yes. And after that I'm going to do a while loop, while keep going is actually equal to y, small y. I will execute these statements inside. Notice I have to have the indentation. Here we are. And this seems to work just fine. Let's run it and see if there is a little problem that we can come up with. Enter your sales, again 60. I'm just making up numbers, commission rate 10%. This is not a well-formatted number. You might want to remember how to format those numbers to make them look like actual money value. I don't want to spend some time on it right now. Let me say 70,000, commission rate 8%, and so on and so on. And it wants me to enter a new sales, and the program seems to never stop. It does not stop indeed, because I did not provide a way for a user to stop it. Keep going was initialized as Y, and then while keep going is Y, do something, and I never updated the value of the variable keep going, which is to say that there is no way for it to stop. It will loop around infinitely. So I have to abort my program, and I will definitely need to add something inside the keep going loop. Keep going will be input. Do you want to enter another commission? And I'll say just yes, no, although as soon as I not put Y, the program will stop. All right. Let's see how it works now. And before I go on, I want to emphasize something. Anything that is indented is going to be executed on every iteration. So just to show you something outside of the iteration, let me print, say just end of program, to see that we have exited the while loop correctly, and after we exit the while loop, we do something else. All right, let's run it again. Enter your sales, 100,000, commission rate 10%, your take is 10,000. Do you want to keep going? Yes. Enter your sales, enter your commission rate. Well, everything does seem to work, and as soon as I don't press yes and press any other button, so don't press Y and press any other button, it stops. End of program. So notice that end of program executed only once because it is not indented with other statements. So if you had some program to continue after your while loop, you could continue it here, indented with while, not inside the while. And that is a good little example for us. Let us go back to our slides. Okay, so basically I executed this very code, and you feel free to stop your video and watch this, examine this flowchart, or find it in the book. Of course, this is an example from the book. Now, a warning about infinite loops: if you don't update the condition inside the loop, that is a variable corresponding to that is involved in a condition inside the loop, it will never stop. So everyone does it. You can always forget to do that, so you just interrupt the program and then you fix your code. If it keeps going, that means that you did not really update it. Update the variable which is in charge, for example, of stopping your while loop. As in our case, in that example, it was the keep going variable. So don't be embarrassed about that. Everyone writes infinite loops, and as long as you are able to see it and fix it, it's not a big deal.